Hi, my name is Ricardo and I'm your host of Math Matters, and today I'm here to talk to you guys about RSA encryption. Now I'm talking about RSA encryption specifically because as a subset of all kinds of encryption you can use, RSA encryption is used to encrypt data, specifically data online that your computer or any computer uses to communicate with another computer or another network securely. So whenever you're communicating over the internet, whenever you're connecting to the internet, the server that you're connecting to uses RSA to communicate securely with your computer and with the network accessing device to protect your information, your passwords, your private accounts, etc. Now, I showed a short worked example of how RSA is theoretically used with very, very small numbers that would never actually be used in practice, just because they're so small and it would take a modern computer nanoseconds, I bet, just to solve that problem. But the numbers I used were these. I used 4 was the message, because whenever we're talking about data that you're trying to communicate, that you're talking with other networks about, you're trying to transfer this information in terms of numbers. And it's easy to manipulate those numbers with mathematics, and computers can do that really well, so can calculators. The number I chose to use in my message was 4. I had to pick 2 primes for my mod. Those were 11 and 5. My public key was 3 and my private key was 7. So those numbers don't mean anything unless you watch my other videos, which I recommend you do before this one, because I'm just going to show how those numbers are communicated in binary, which is the language for computers. So computers don't communicate in the same number system we do, which has the thousands, hundredths, tens and ones place, or hundredths, tens and ones place. They don't have the same kind of place system. They have powers of 2. So they only have zeros and ones, as you've seen, like a lot of media portrayals have computers just listing off seemingly endless series of zeros and ones, like, you know, in an unintelligible fashion that pretty much means nothing. Those are all numbers. Those are all numbers in a really complex binary form. Complex to us because we can't understand it, but actually way more simple because it only uses 2 numbers, right? Zeros and ones. And the places they have aren't ones, tens, and hundreds. They have ones, 2s, 4s, and 8s. That's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Instead of 10 to the power of 0, ones, 10 to the power of 1, tens, 10 to the power of 2, hundredths, and 10 to the power of 3, thousandths. So it's kind of the same idea, just they don't have the base 10 system. That's what we call it. They have a base 2 system. So let's just show how this is calculated. These numbers I calculated myself, and let's show 11, for example. 11 has 1, 8, because the 1 is in the 2 to the power of 3 place. 1, 2, because another 1 is in the 2 to the power of 2 to the power of 1 place, which is 2. And 1, 1, because the last 1 is in 2 to the power of 0. And 8 plus 2 is 10, plus 1 is 11. Makes sense. Notice it has a 0, or an empty, where the 2 to the power of 2 is, because it doesn't have a 4 included in it. And you just kind of have to add these numbers up. And these can represent any number in our base 10 system. If you want to learn a little more about base 2 and binary, I recommend you look that up because it's really interesting. But here I have a bunch of smaller numbers, and none of these actually use the last place 0, so it's kind of unnecessary to write that. But here are some binary examples. So these, however, relate to the numbers I have in the middle here: 512-bit, 1024-bit, 2048-bit, and 4096-bit. So what do these bit means? Well, 512 bits means you have 512 zeros and ones. That's 512 places in a binary number. So this is 3 bits, for example. This first number is 3 bits. So are all these other ones, and this is 4 bits. So if you think a 3-bit or a 4-bit number is hard to come up with, think of a 512-bit number, and those are easily read, understood by computers. So that's essentially how computers deal with the numbers that I've been talking about. But what does this 512-bit number mean? How can we compare that to the numbers I used? How is it that much harder? Well, first of all, these are, just incomprehensibly large numbers to multiply, because I had to multiply P1 and P2 to get my mod, and then I had to divide the mod and get the remainder, and it was just incredibly complex. In fact, I had to take the message to the power of 3 4 to the power of 3. That's simple, but with a giant number like this, it would be nearly impossible to do, at least with the calculator by hand. And by nearly impossible, I mean literally impossible. You would never do that. But a computer can do that, which just goes to show how powerful our computers are nowadays. But to show how far they are from this level of power, let's think about how big this number is and how long it would take to crack an RSA code with this 512, etc. bit encryption. 512-bit encryption is the same as a 155 length number. So if we're talking about normal numbers in base 10, where we use, tens place, hundreds place, thousands place, it would be 155 just numbers long, not letters, numbers long. Okay, it's pretty large. Well, did they crack it? How did they crack it? Well, the way they crack that is through brute force. And with all of these, I'm going to be talking about brute force method of cracking. And brute force essentially is trying every option and making sure that one of them works by trying every single one, plugging it in, and seeing if it works. That means trying every single 155 length number. That took some of the most powerful computers at the time 6 months. This proves that inherently 512-bit encryption is unsafe for any kind of encryption, ever. Because it took 6 months to decrypt does not mean that that's a high enough standard. Technology will only get faster, this time will only decrease, and when there is a 512-bit encryption being used, people who aren't aware of what that means, even companies who aren't aware of that means, show cyber attacks, and cyber attacks are sometimes commonplace. In fact, credit card information is often stolen, and it's not from whenever it's stolen, like a bank. You steal money from a bank, it's whatever money is there then. It's often credit card information from several months back is stolen because it took whoever broke in, whoever tried to use brute force, it took them several months to decrypt it. And taking several months is a lot of work, but it reaps a lot of benefits. That's why only 1024-bit and on encryption is used. Now, what is the highest bit that has been decrypted? Well, the highest bit that has been factored is somewhere between 512 and 1024, and it's exactly 768 bits. The highest reported factored bit length. Now, if we think of binary, that's 768 binary numbers in a row, either 0 or 1 options for each number. So there's 2 options for each number. We're trying to count how many options there are total. 2 options for each number, times however many numbers there are, in this case 768, times itself for that many times. That means 2 to the power of 768 possibilities. And it took some of the most powerful computers in the world 4 years to crack this. And it's not safe, because it's been cracked, we know it's not safe. In fact, with the current processing power that has been demonstrated, 1024-bit, if you're asking yourself, well, how long would that take to decrypt, and am I safe? 1024-bit would take about a decade, and no one has that time on their hands to spend a decade trying to crack it. In fact, if the US, for instance, bought a $10 million machine just for cracking the code, it would take over a year to crack a $10 million machine, which no one has the money to spend on, but it would take that long on estimate to factor a number this large. And it doesn't increase by 2 every time, it increases hugely exponentially. It would take several billion times to decrypt 2048-bit encryption, and for 4096-bit, it's incomprehensible how long that would take. Therefore, 2048-bit is usually used, 1024-bit is perfectly safe and often used, and 4096-bit is slowly becoming the standard. That's how you know that no matter what you have on the internet, you're in good hands. Hi guys, thank you so much for watching my video, it really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video in my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember,